array to see all of that stuff unfold, and then we'll let that process just slowly evolve. So enough with the setup, let's jump into some of the code because it's fun to see those things actually evolve. So let me change my screen to my Safari page so I can show these little heat maps and all of that. So at the very top, you should see a whole bunch of helper functions. So all I've done is I've just pulled in my matrix multiply, I've pulled in this power matrix, and all of that stuff. So the first thing we have is the weather of Oz example. So I have my weather and letting that process evolve. I'm printing that thing out. And then what I've done is I've just computed various powers of that thing to see what's going to happen as that system kind of does whatever it wants to. So you can see that after a few generations, we ended up getting some stability emerge. So we get, the 40% of, whatever that first day was, rainy, 20% of nice, and 40% of snowy. We get that kind of nice evolution. Same thing happens in the voter redistribution. So I have my matrix of votes. I can multiply that thing by these kind of breakdowns of what the population currently looks like. So if I have everybody Democrat, I can see that it kicks out that 80-15-5. If I have the even money between Democrats and Republicans, we get the 50-40-10 breakdown. If I have even money between everybody, then you can see that it kicks out something like 40-30-30. And then that weirdo one that appears to be stability, so the 50-28-22. So if you feed that in, nothing really happens. And that's the one that emerged from taking that matrix and raising it to a fairly large power to see some amount of stabilization actually occur. So we get 50, 28-ish, and 22. So that becomes that point where I'm not moving around anymore. And if you want to kind of see the evolution, just have it all in a for loop to kind of blast through those various powers of that matrix. The next one is where I'm going to start actually having in some of this coloring. So here was this drunkard's walk. So here was the idea of me moving forward at 50% or backwards at 50%. So what I've done is I've actually pasted that thing and I've used this Sage command, which is called matrix plot. So Python's got some of its own stuff to do it. It's just going to be indicated a little bit differently, but it's this ability to create essentially this heat map, which is going to really darkly color things that are ones, white out things that are zeros, and then grayscale everything in the middle. So here's the idea that if I start at 0, I'm guaranteed to end at 0. And if I start at the bar, so 4, I'm guaranteed to end there. And then the stuff in the middle is going to be the gray transient states. So the idea is that I can take that and I can blast this thing through. So here was state 1 and then state 2. We get a little bit of movement in the middle stages. So again, it's this kind of race to the edge. What you can see is that the middle one maybe darkens for a bit because we had people that started in 3 and they might have moved to 2. And we had people in 1 and they might have moved to 2. So there's kind of a temporary suck in the middle, but then they're going to be dispensed out again. So if you animate this, so that's what's happening here. So you can see the initial process and then the slow evolution of things running to the edges. So here was the final breakdown of like 100% if you start at 0, and then it was like 75, 50, 25. So that's that grayscale that's going to be emerging. So you get this kind of nice visual of what's actually happening with this big exponentiation that's taking shape. So it's kind of this cool watching this system actually evolve. I got the same thing for the nice little rat maze. This one obviously takes a little bit more effort to type in the big ol' matrix. So this was what, like a 9x9 matrix. So the initial version of it looks like this. So here you have your nice little sinking point or your absorption point. So if you're at 8 or 9, I guess on that one, you would stay put. You get another what appears to be dark thing, but notice that it's not along the diagonal. So this is just telling me that if I was at location 2, I have to move to location 3. So if you remember the little rat board, there was this top right corner that forced me down. So there was this idea that I think it was numbered 3. And if you were at 3, you had to come down to 4. So if you animate this thing, you're going to see, I'll give it a sec to restart. What you're going to see is that there's going to be this race to everything being pushed to the right. So what that's telling me is that if I start in location 0 and I let up to 50 generations occur, more than likely I'm going to end up in that absorption state 8. If you started in location 6, that happens really fast because that was the one that was right above the final absorption point, and you kind of just blast that all in very, very quickly. And then the last one I have is the nice little chutes and ladders example. So here, again, is that terrible little matrix that's formed. If you let that system evolve, oh no, I don't got that one animated. Oh, there it is. Okay. So as you animate this thing, again, it's going to be this super duper fast race to everybody kind of being at the final state. So it all darkens in and you're good to go. So again, it's kind of fun to see these things. It's not a specific thing that we're going to dwell on for a while. It was more of a, hey, we have this matrix multiplication and we know how to compute powers. So let's look at a couple of these cheesy little models and be like, hey, we already have the tools to attack these things. So let's just kind of rebrand some of these finite state machines, give them some probabilities, give them some kind of the cool little flavor of what's happening in the world. And you'll see some kind of interesting applications in some of the activities in the future. Is that I got some kind of fun little scenarios for you guys to kind of see the systems evolve and what ends up happening. So again, kind of this play on birth and death and zombies and all of that kind of stuff. So with that, I'm probably going to end the recording and then open it up to just a little bit of chat if you got some questions. So I apologize for blasting you with a bunch of stuff, but I wanted to kind of get through all that so you guys could kind of work a little bit more early next week, and we'll go from there. So I'm going to stop.